Let's get going. How's it going? Going good? Yeah? All right. Well, we didn't go over any big Ruby concepts last class, so are people comfortable with the concepts that we did talk about, composition, and I can't even remember the other ones that I specifically covered. Abstraction, composition, and algorithms. Sort of the building blocks, some of the core building blocks of any programming. All right? And I think what we'll do is we're going to start with a little bit of overview, but also introducing some new stuff with arrays and methods again. And then we'll introduce recursion, which will probably annoy you. Hopefully it bothers you the way it did me when I learned it. Otherwise, you guys are way better than me. And then we'll get into talking about objects and object-oriented programming a little bit today. This is just an introduction. We're not getting into everything around it, but it'll be a topic we'll go over for the rest of the class, building on that knowledge more and more. So start with arrays and methods. I think this is just a really good one. I stole this straight from what Ramiro had before, but we've already done some of this. We've passed arrays into methods. And so here's a great example of building a simple method that will reverse an array. I know that the array has a reverse right on it, but here we can write our own. And I just want to make sure, do people feel comfortable with what's going on in this function, this reverse?
Oh, that's just the name of the array.
Yeah. Yeah, that's the new array that was created so that we can return it. All right, then as a group, let's try and go through some of these exercises just to reiterate some of this. I'm gonna go ahead and just capture these into a Scratch file. I already have Scratch. How am I found? Oh, I moved it. All right, where'd my Scratch file go? I do have it, right? There we go. So I'm going to put this stuff in here just as comments so we can work through these one at a time. And then let's go ahead and try and work through these problems. So the first one is a method that takes an array of ints and returns an array with each integer in the first array increased by 3. So let's just create an array of ints that we're going to use. It seems fine. So how can we get started with this? I'm going to do this first one, a method that takes an array of ints and returns an array with each integer in the first array increased by 3. You got ideas on where to start? What? The arrows? Well, what about what? Should we have a function or a method to put our code in first? Yeah? So let's define a add 3 and then ends. So it determines that we're at the end of it. So now we've got a method. Is this method going to work for us as it is right now? We're reading through what we're trying to do. A method that takes an array of ints. Is there anything missing on this right now? What? There we go. We need to have a parameter. So let's give it an input. And then, as I've said before, what I'll do a lot of times when I'm writing code is before I actually write the code, I'll put comments in placeholders of what I'm going to write. So now I've got an input, and I'm going to go for each int in input. Add 3. I'm sort of missing something here, because where am I putting this result? Where am I putting what I'm...
You push it.
Okay, so let's create a new blank array. Add 3 and push the result to the new array. It seems like we got good logic there. Now, what would be anything else we need to do with this method we're writing? Let's start filling it out and we'll see. So create a new blank array. This should be easy. I think we should all feel pretty comfortable being able to do that. How am I going to get each item in the input array? Input.each? All right. That sounds good. This is where, no joke, being lazy could be useful, because I'll do stuff like this a lot of times. So I'm just going to go ahead and steal something straight from somewhere else, just to make sure I do it correctly. Now I need to change to input, which I think is still better, but input.each item, okay. Then we need to end that, right? So what do we want to do for each item? We want to item plus 3. We can do that if we want. What? Yeah? All right. But item plus 3, like that? Sounds good. All right, we're gonna need to call this, right? Let's put the result. This. Does this look right? Are we ready to try and run it? What? Ah. Return output, right? Okay. Let's see what we got. Four, 5, 6, 7, 8, 9, 10. Looks good to me. Looks like we added 3 to each one of them. All right. That one's pretty straightforward. So let's move on to the next one. A method that takes an array and an integer and adds that integer to each element in the array. So this looks like it's just maybe a little bit of a slight shift on our previous method, right? Hey. Oh, you're good. I had no idea that there would be all crazy going on down there, so.
It's going on a lot now.
What?
It's a lot of people.
It's a lot of people, yeah. I don't know if it's as many as the other one, but it's going to be close, I think.
Probably more.
You think so?
Yeah, it starts right here. Beta, all the way to City Plaza.
Oh, man. Wow.
I'm glad to do it.
All right, so any suggestions on what we want to do to tweak our, this time we want a method that takes an array and an integer and adds that integer to each element in the array. So maybe, let's just change this. Add number. Sounds good. Because it sounds like we're doing something very similar. Now, if we're reading what we're trying to do here, again, a method that takes an array and an integer. So let's add either value. We'll call it increments. That's what we're going to increment by. Okay. And what else do we need to tweak on this to make this work? So now we're bringing that increment in. We need to add it to each item in the array. Replace 3 with increment. All right. And now let's change this call. And what do we want to increment it by? 5. Make it 10. Make it really easy. All right, let's see what we get. I want to change the order of these screens. Test that out. Cool. Got that working. Now, I'm going to add something extra in here just to help us think about calling a function inside of another function. We've got a nice, what I would call more generic add number method here. Now let's rewrite our add 3. But let's do it, instead of writing all the logic here, let's see if we can reuse the logic that we already have in add number. Any ideas on how we can do this? Let's do add 3 again. No, we're re-implementing our add 3. But this time, since we've created a generic sort of add number here, instead of writing a hard-coded add 3 version of this, we've got this one. Let's try and somehow use that add number to create our add 3 method instead of creating it directly.
So you say when you add 3 on the add number.
So you're saying call add number? All right. Let's see how this goes. So if I'm calling add 3, I don't need this second argument, right? Looks good to me. That's going to be a really useful pattern to think about, is when you're writing code, try and create generic, useful base capabilities and implement specific instances on top of it that can call down into them to accomplish more work. So instead of having to write separate this same loop in each one of these, we're able to create this more generic add number and then create specific ones if we need them that call down into it with their own parameters. Does that make sense?
This is a question. Would that be considered a wrapper method, or is that not the case? Or is the definition one of those like gray areas?
Yeah, it's sort of gray. A lot of times, I mean, I wouldn't necessarily call this a wrapper method, because I think a wrapper method, I mean, if you're thinking of something that's just wrapping something else, is usually more like this. Let me wrapper add 3. Dang it. I need to get some better Ruby. Do I have Ruby in here? It's got Ruby, but it doesn't do a good job. So I would think of a wrapper method a little bit more like this. Maybe. Where I'm not necessarily changing like it, but I might do something. Well, this one's gonna be hard.
Yeah.
I guess, I mean, I can just do this. Or what I'm doing is adding some additional functionality on it, like logging or something like that, and then still calling down to the base one.
Like a recipe of
Sort of, yeah. It's a very common pattern in testing.
Yeah.
Because you're wrapping it so that you can get some additional logic around it. It's also common, I can't remember what it's called off the top of my head, in objects. I mean, proxy is one terminology where you proxy it with something else. And then that way you could do all sorts of additional logic if you wanted to, while still calling down to the same logic underneath. All right, let's do this last one. This one's gonna be a little trickier. A method that takes 2 arrays. All right, so let's add another one. And returns the pairwise sum of the 2 arrays. For example, 1, 2, 3, and 5, 6, 7 return 6, 8, 10. All right. So this one's gonna be a little trickier. But we know we wanna take 2 arrays. We know we're gonna want a blank new array that we output. So that's good. This is definitely trickier. But not impossible. So for each item in the first array, again, I'm going to take notes here. The same item from the second array, add them, and store the result in the new array. Okay. So let's see. I have first dot each. There's better ways to do this type of one, but something like this. So let's get the item. This is where it is a challenge. I don't know if I'm interested to see if anyone comes up with an idea, because I don't know if we've necessarily talked about the way you would do this. So maybe someone's going to come up with a creative solution right now.
Would you have to do a nested loop?
Could I have a nested loop?
Yeah.
So I want another each
So, yeah,
inside of here.
but I guess before you do that, well, no. Yeah, second that each do, and instead of calling the item.
Okay.
And then after that, you say output the stream item plus no.
All right, let's see what happens. Sorry. Used to, yeah. Although I actually strongly prefer, yeah, yeah. I think it's a lot easier to read. Whew. That looks like we got a lot more than we were wanting.
Yeah.
Any idea why? No? It's a good guess. So if we walk through this code that we have right now, and we try and step through it, let's make it these really small so that we don't have to. Another very common tactic when you're debugging is to make something much smaller. I think somebody else just showed up. So that you don't have to deal with as large of a case. Makes it easier to try and find what's going on. Okay. We ended up with 12, 13, 13, 14.
Is this how it showed up?
I think so. I could be wrong, but I heard a bang. Mike, let me check. No, that was just my wife.
Okay.
So let's step through. First each, so we get item, which will be 1. And then second each, so we will get 11. And now we have output equals 1 plus 11, so 12. That's what we expected. Now we hit end here and we go back up the second dot each. And we get the second item out of second, 12. So 1 plus 12 is 13, and we add it here. Okay, now we don't have any more items in our second array, so we go down here, we get the first dot each, we get the second one out of that array, 2, and we come back in here again, second dot each. Oh, 11 is what we're gonna have, so that's how we'll get 13 again. And second dot each is 12, so 2 and 12 is 14. So what's going on is, since this loop, this second loop is nested inside of the first loop, every time the first loop runs, it's going to run completely through the second loop every time. So that's not quite going to get us what we want.
Can you loop through both arrays at the same time?
So there's a lot of different ways to solve this, and I think there's let's try and do it right now. I'll show a couple different ways to do it. But this is one of the great things about programming is when you run into problems, a lot of times you can solve them in very different ways. So let's do something interesting here. Let's do output is item plus second dot first. And then, I mean, this has a side effect.
Yeah.
So it's not necessarily what you would love, but do you know how to pull off the front of
Unshift.
unshift?
Or is it shift? Might be shift.
Yeah, I think it's shift.
Yeah.
Okay. I think this would work. I'll check. We'll see. But what this will do is it gets the first item in the second array and then shifts that array so that the array gets rid of that first item. Let's see if it works. 14, that's what I expected. So what's going on when we walk through this is we have 1. 1 plus 11 is 12. We store that. And then second dot shift, what that will do is take this first item out of that array. And now that array just for a second just contains 12. Now, the only problem with this is there's one side effect. which is if we look at the result of the array that we sent in afterwards, which you can't see here, but it's empty now. We actually changed the array that we had passed into this method. So maybe we don't want to do it that way because we're not interested in changing the actual values. Another way we could do this, and I definitely prefer iterator approaches because it just works better most of the time. But we have looked at, I didn't introduce for loops, but I did introduce while loops. So, well, yeah, I didn't introduce the traditional for loop structure. So maybe we can try it with a while loop instead. What? So what do we want our condition to be here? If we want to try and walk over these array items. What? Well, what if we, I think there's a lot of ways to do this, but let me try something here. Let's say, put index equals 0. And we're going to use index in here somewhere. How can we use index to help us accomplish this?
So we can put like, well, we could have to know how many numbers are in it, which is what we have here. But
So how do we get the, how many items are in an array? Okay. So first dot length, let's try that. So while index is less than first dot length, now what do we want to do? We want to add something to output, right? So if we're trying to grab, how would we grab the first item out of this first array passed in? How do you grab the first item in an array? What? With an index of 0? So you could do index, right? Because it's 0 right now. Okay. And how are we going to get the first item out of the second array? Okay. Yeah, there you go. You got the gotcha so that we don't end up here forever. So we need index to increment so that we're going to increase it.
Can you do index plus plus?
No, I don't think Ruby has plus plus. So now we're going to increase our index each time, and then we'll run through this again. So we've gone through it once. Now index is 1, and we'll get the item at position 1 and the item at position 1 out of each array. And it'll hit the end, and now it'll come back up here. Index will be 2, but 2 is not less than the length. So we should exit out at this point. Uh-oh. Looks like I have a bug.
What was there?
What?
What was there?
I don't know, at home. So let's see. I don't know. Might have just hung for some other reason. Maybe I need to save it. No, should be good. Yeah, it's hanging, that's for sure.
Why did you put the do on the line?
Why did I put the do? It's, I don't know if you need it. It's the syntax for starting a block in Ruby, and some blocks require it and some don't. So a while, I believe, is flexible enough that you don't have to specify it. But, all right, it's not working. I'm not quite sure what's going on. You want to have an idea? Maybe,
Yeah.
is this syntax wrong? Is that the syntax?
No.
What?
You had it right before.
Oh,
Yes, one.
yeah, yeah. Okay, I see it now.
Yeah.
I'm adding 0 to it every time,
Yeah.
right? There we go. So good thing to learn from this assignment is that you don't always solve stuff with the tools that you've used before. You may be used to using the .each to iterate over arrays because it's the easiest way to iterate over one array, but maybe it's not the easiest tool when you need to work with multiple items at the same time. It might be useful to be able to think outside the box and go, oh wait, I've got some other tools that let me loop over stuff. Maybe I can use one of those instead of .each, and I can accomplish that task easier that way.
Also, there's an each with index.
What?
There's an each with index.
Yeah. I'm not going to show other methods on them yet. We may come back to some of these and show much easier ways to do it. But people feel comfortable with that? Okay, so I want to introduce just a couple, or reiterate a couple concepts. First, pass by reference. We talked a little bit about this in the last class, the confusion over how you can somehow change the value of something outside of the array, where if, say, I reassign a string, or outside of the method, like we just did it, for example, with second in our first example, where we changed the value outside of our method of that array. And that's because pretty much Ruby uses something called pass by reference, which means that when you're passing these variables around, like our arrays that we just had, we're going to have these two different memory areas, because we're going to come back and talk about this a little more. And then we add second. And we have some others. And then these are referring to another area in the computer, another set of memory locations. So first was pointing to this location, if you will, that had 1 and 2 in it. And second is sort of pointing here, which has 11 and 12. And by default, what happens when you call a method in Ruby is it passes another reference to this location. So inside of our method, where we have first and second, or actually let's change these because these were called inputs. And I think it was called second. And when we call our method, we created first and second. They're unique and different than what we had before, but it just so happens that first points to the same memory location. So that's what it means by reference. It references this same place in the computer. And second references this same location. Which is why if you changed, like we did the shift on second in our one example, we changed the values that were in here until we deleted them. And then when we stepped back out of our method and we looked at this second, the array was empty now. And the array was empty because we had changed the actual values that were stored there because they're both referring to the same location. It works different when you create a new array where you assign it to a new array. That's why when we're creating arrays inside of here and returning them, what happens is, even if we change second and pointed it to a new array instead of changing it directly, then second inside of the method would now point to another location with the array values instead of the original. What you did was you changed what it was referring to. So that's known typically as pass by reference, which means you're passing a reference to that same memory location. And it's going to be something that is both very, very powerful because it allows you to, what?
Save memory.
It allows you, yes. Probably the biggest reason is it allows you to save memory. It can be tricky because you change things when you didn't intend to, but we're dealing with something very small here. We're dealing with arrays of 10 items. In a real computer, you might have an array of 1 million items, and it would be very costly to pass by value and copy every one of those items into your function. It's much, much easier to just point to those items and work with that. But it can have some side effects that might be tricky or that will trip you up over time. Do you have a question?
So, when you validate,
Yes.
the information value,
What's that?
so when you validate the input value is 1 and 2, and also 1 and 2 value, so you can keep. So you said the input and the parts two they share the same information.
Yeah, they're pointing to the same data in the computer.
So when you validate the input address, what happens?
Ah, yes, that's a good question. So I think I get what you're asking. In a real erase. It's okay. I'm good. I just don't want this filled up with all this other garbage. What?
The monitor.
You see one? Yes, thank you. I just couldn't see him. All right. No, that's a good question. And we're not going to go into too much detail on the way that this works in Ruby right now. But the concept is Ruby is what's known as a garbage collected language. So what's going on inside of Ruby all the time is it's checking to see if there are any references that point to values. And if there's a value, if there's actual data over here that nothing points to, it will eventually delete that content. So what could happen is if we changed input and we said input, we didn't change the values of input, but we said input doesn't point to this anymore. Input equals nil, for example. That would be like deleting this pointer. Now, as long as we're inside of our method, we still have first pointing to those. So that's going to stay in the computer. It's going to know that those are there. Once we step outside of that method, then first won't be pointing to them anymore because we're out of the method and that doesn't exist. This will still actually be in the computer sitting there and taking up space until Ruby goes through and looks and says, what do I have over here in memory that nothing points to? This is an item that nothing points to. And what else? And then it will come around and delete anything that nothing points to free that up to be used elsewhere in the code. It's not something that you probably need to know too much about right now, but it's the details of how Ruby's handling it is, you've got all this memory assigned, and then when you don't have anything pointing to it from your references, it's able to delete it. Does that answer what you're asking? Yeah, that's what I thought. That's a good question. It's a very important topic in computer science. There's actually a lot of active research that takes place around those, and languages can implement the way that they do this differently. So some languages, like Ruby, I believe, uses what's called garbage collection, where it will check, it'll go scan and look for this. Some other languages use different implementations. One that you'll run into is called automatic reference counting, if you do a lot of programming. And what that means is instead of the language having to scan through here and look for any references, it is always keeping track of how many references there are which requires it to have a whole nother area of data holding on to these references. And whenever they get deleted, it tracks that and it's like, oh, you've got one less. And then, oh, first was removed also. Oh, then I have nothing pointing to this, get rid of it now. And that's a slightly different approach versus a garbage collected one, which when it goes to garbage collect, it has to scan through here and see if anything's pointing to those locations. Okay, I think that covers pass by reference well. And that's, I would discourage changing the actual item. I encourage trying to return something new, but sometimes there is some value in it. This is a very small example of being able to write a piece of code that changes the
Could you for change? It should be
was not what?
When you put change, the last one it should have a.
Yeah. Yep. Well, you can. So it's a little hard because of what happened there, but if we look at that, let's define A again. A equals 1 and 2. Then if we call change A, and now we look at A equals 1, 2, and 3. So we didn't change it directly with our line of code here. This change method added a new item to the array. And since it was passed by reference and pointed to that same location, it added it right to where Ray was referring to stuff. So that's not too bad as a concept. The next one, this one's a lot more interesting. And this is recursion. So I went with an old horror movie trope here. The call came from inside the house. Recursion is the concept that a function or a method, we just, for example, in our Scratch a moment ago, we had the add3 that called add number. So it called another method. We're relatively comfortable with that concept. But recursion is the idea that a method can call itself. So you can call back into yourself. I'm going to copy this over to our Scratch, and then we'll talk about it in more detail. Recursion is a very, very powerful tool. It's also a little hard to understand. I'm going to change this to fully say factorial. So if you're familiar, factorial is just a factorial of 2 would be 2 times 1. And a factorial of 3 is 3 times 2 times 1. And 4 is 4 times 3 times 2 times 1. So what we've done here is we've got a very, very simple function or method called factorial that just takes a number. And when we call it, like we did here with factorial of 5, we get out 120, and what it's actually doing is calling itself. Whenever you do a recursive function, we probably won't go into too much detail, but it's a very useful thing to know. You need to have what's known as a base case, and then you need to have your other case. So in this one, the base case is when n equals 1, return 1. That's how we get out of this recursive loop. But if it's not 1, return n times the factorial of n minus 1. So let's go ahead and whiteboard this out because it's a little confusing when you first encounter it, but it's a very, very powerful tool. I'm not going to do all the way to 5. I think I might just do 3 because it's a little easier. Are people able to see the whiteboard just fine too? Is that okay? Somebody's making some good speeches out there. They did, yeah. They were much more organized too. They actually got started on time than the last one, so I was impressed with that. That was, oh yeah, props to them. They knew what was up. They were ready for it. So we called this with 3. I'm going to shorten it now because I'm lazy to facts.
See, what I'm thinking is happening goes down to the return in time factorial in, -1 and putting that -1 is equal to 5. Go back to the top to 4 and multiply and then come back again.
Yeah, close, yeah. So if we call this with fact 3, then let's walk through the code. We're definitely not 1, so we're in the else statement. So what we're going to do is return 3 times factorial of 2. Okay, so factorial of 2, breaking it down, we'll call back into our same method and we'll say, okay, is n equal 1? No, it's 2. So we'll return, this becomes 2 times factorial of 1. Okay, so now we call back into our same function. We've got 1, so if n equals 1, it's 1. So that's going to return 1. And now it's going to go back up through all of this code. So now it'll go, all right, 2 times 1 is 2. So I can sum all of this up as 2. And now that's fed into here. 3 times 2 is 6. So now all of this returns 6. And that was my original call. So I can return. This is a very, very powerful, very powerful concept. In fact, math, you can sit down and do the math and prove that everything that you can write using loops that we've already done, while loops or anything like that, you could also write with recursion. However, there can also, it's both very, very powerful and strong because it lets you do some amazing things. It can also have, especially if it's not done very well, performance impacts. Because if you're looking at this carefully, what you'll see is this factorial 3 doesn't resolve until we've resolved the base case down here. Which means in code, it's managing every single one of these function stacks or function calls at the same time. That makes the memory requirements expand very rapidly when you're doing recursive calls because it can't just dump the information. We talked about garbage collection just a moment ago. You can't garbage collect any of the content from your other calls to factorial until it reaches the bottom because they're all still being referenced. They're just nested inside of each other over and over and over.
So depending on how large the number is,
Yeah, it can slow it down really fast. Let me try something here. I'm guessing this might, yeah, that still went really fast.
it's a computer.
Let's add one more 0. Oh, I'm impressed. Computers have gotten a lot more powerful than they were when I was doing this stuff originally, because I could easily trip it up with something like that before. Now we also have a very, very simple program that we're running in terms of this factorial. And so Ruby might be able to, when it actually compiles, optimize this code to instead of actually being recursive, to flatten it out like the if statement. Some languages are smart enough, depending on the way that they're structured, to convert your code to the if statement version or the loop version that works better for the computer program, but might be harder to reason about. You'll see if you stick with computer science or studying this stuff, you'll see a lot of recursive function calls. It's a very, very popular thing to do, especially in functional programming paradigms, where you call down into that function again and again. Prime examples you'll see are factorials. Trying to think of the other one that's really popular. Why can't I think of it right now? I don't know. I may even have you write this other one as one of our programming assignments once I remember it. But are there any questions about that? I wouldn't be surprised if there are.
You will always have that pattern of like an if statement inside of
It doesn't necessarily have to always be that way, but it's going to be something like that. When you're thinking of writing, if you're ever writing a recursive method, you should always, the first thing you should think is, what's my base case? What's the way I get out of this set of calls? Because if, on our factorial example, if we didn't have a base case, which was factorial of 1, and we kept calling into factorial, then we're going to crash our program. If instead of this I did factorial of 1 here, because I don't have a base case that gets me out, then I am going to hang it. It's going to blow up here. Stack level 2D. See, that's it yelling at me. That's saying, I tried to call way too many times down, and I'm smart enough to tell you, no, you did something wrong. So instead of it crashing on me, it actually warns me about it. But yeah, whenever you're writing recursive stuff, you need to think in terms of a base case, and then how will I get down to that base case in my other case? And there might be more than one other case to get down towards the base case. I'll probably throw some examples of that in. Yes? Yeah.
So you could like you could put 0
If I put what?
0,
0?
So the return would be 0.
The result will be 0 because anything multiplied by 0 is 0. And when we get all the way down to our base here, instead of 1, that's 0. So 0 times 2 is 0, and 0 times 3 is 0 when it goes back up, yeah. So you need to make sure you have the right base case. Factorial is just probably the simplest recursive example that you can give. There's other ones that work just as well. We could, for example, we could go and redo some of our array examples that we've done as recursive versions of functions instead. And that's very possible. All right. Now, looks like it's a little later than I thought it was going to be by this time. So we probably won't get through everything I wanted to talk about here, but I wanted to introduce the concept of objects and object-oriented programming. We're not going to go into everything around this. It's going to be something we're going to build on bit by bit. But object-oriented programming is really the fundamental paradigm of Ruby. It's one of the most popular programming approaches that exists. And so it's really important that you understand the way it works, especially if you're working inside of Ruby as a language. All an object is an encapsulation of state and function. By encapsulation, it just means that it takes some state and function that can be performed on that state or work with it and store it together so that it's all grouped and easy to work with as one entity. State is just properties. Mostly it's variables that we're used to. Properties, variables, characteristics of an object. And then function is just the behavior of the object. In our case, that's why we've been interchangeably talking about function and methods, because functions on an object are known as methods. It's just methods that can be performed with the object. So I wanted to go with something simple as a reference. And if we think about this stuff, am I going to be able to open this? I should bust out my knife. I got it. 2039. Go ahead and take a pencil and pass it around. That might be enough for everyone. And then, as a group, let's try and figure out some of the characteristics, some of the properties of these pencils. So what are the properties of the pencil you have? Do you want to write these down? Sure. You want to write down what they?
Yeah.
I want to be over there just so I don't have the audio for the class. Let's go with this one. What are some of the properties of the pencil?
Plastic.
Plastic. That's good. Lead.
Lead.
All right.
Got an eraser.
Eraser.
New,
What?
new,
New.
New. That's good.
color,
Color. Yep.
color.
Yeah.
Oh, you say color?
Yeah.
I mean, this hanger.
It's got the clip.
Hanger.
Sure. What? Yeah, it's got a spring. It's made in China. Of course it is. I got them at the dollar store. What? Brands. Brands.
Brand.
Name, I mean, yeah, name, size.
Yeah, size.
Brand.
Right. So if you just looked at the pencil without trying to describe it, and I could rattle off at least a half dozen other things off the top of my head, because I can easily say the lead size, the number of pieces of lead,
Chamber.
yeah, there's a lot of aspects to it, right? You look at that externally, you don't think that's a very complex object, but when you start trying to describe all of the properties of it, there's a lot of properties that go into this pencil. This is the same as any object that you work with in a programming language. They're going to have a bunch of properties, and those properties are characteristics, aspects of that object. Now, not everything maps quite as concretely as a pencil to your programming language, but it's useful to think about them that way. And so one of the assignments we're going to have is I'm going to ask everyone to just choose an object. You can choose whatever you want, but I suggest choosing something simple because you can see how complex a pencil was already. Choose an object and try and come up with as many properties of that object that you can. So you can try and describe it in a whole bunch of different properties. It's a very useful way to think, and it's useful to develop that mode of thinking when you're going to be doing object-oriented programming. So that's what state, all those properties we described, those are state aspects of the pencil. But now let's change over and let's talk about what are some of the functions. What are functions or methods or actions I can take with the pencil instead? Instead of the state of it. Writing. Erasing.
More lead.
Right.
Replenish, yeah.
Yeah.
Replenish heat.
Deconstructing.
Give me a cheat.
Erase you on it. You can. I do this a lot with my pencils. I use them to flip around in my fingers all the time. So, I mean, there's a lot of function that you also have with it. So in that same assignment where you sort of choose something and you're going to try and break down the properties of it, I also want you to break down as many functions as you can think of for the object. This is the same way that we think about objects in object-oriented programming. You try and break it down. What are the properties and what are the functions? You try and go with very, very small objects so that you can build something up. So in that vein also, and we'll come back to this, what are some of the smaller objects in that pencil that the pencil is composed of? If we were to break it down into component objects. What? Lead. The tip, the eraser, the spring, yep. And that's also yet another step when you're doing this object-oriented thinking. You're breaking it down into these very small component pieces. Each one of those is an object itself that has properties and methods. The spring can be compressed and it can extend, and properties are how hard it is to compress it or the material it's made out of. So I think this is just a really useful way to think about object-oriented programming and to start off with. We're not going to get into creating our own objects right away, I want you to think about the world in terms of objects, especially small ones. So try and choose something. Choose something like a bouncy ball or a key or something basic, right? A sucker, gum, something simple, and try and describe it in terms of properties and methods on it. And maybe there's even sub-objects that it's composed of. That's going to be a really useful example for you. So bringing that back into our programming. In Ruby, everything is an object. Objects everywhere. Everything that you work with in Ruby is an object. And I've sort of hinted at this a little bit in class so far, but we haven't talked about it in too much detail. If we flip over and start looking again, we can see that I've talked about it a little bit where I had, say, hello world. And this is an object. And we saw that when I did object ID. And we get an actual ID for it. Everything that you work with in Ruby is an object. Even nil is an object. Nil.object ID is 8. And one interesting thing about nil that's not the same for everything else is everything that refers to nil refers to the same object. We'll talk about that in a minute. Because there's only one nil. So everything is an object. Everything that we've worked with so far is an object. Every number, every array, every string, those are just objects. So let's go ahead and create a few. That we can work with going forward. All right, we've got a few objects fed in here. But these are all objects that we're already familiar with. This is a string object. This number 42, this is what's known as a fixed num object in Ruby. And this is an array object. We can also create plain objects. We can create objects from scratch that aren't of any of these types. They're just the most base level object. And we can do that with object.new. So I'll go ahead and create a couple. We'll create thing 1 and thing 2 for anyone who's a Dr. Seuss fan.
Who is it?
So now we've got a couple new objects. They're a little different than what we've had before, but a couple new ones. This is the simplest way to create a very just low-level object. Object.new. Object itself is, we'll see if this works, it may not. Object is an object, it's just one that's sort of built in there down. So an important aspect of these objects, getting back to our reference, passing by reference and the way this stuff works is the uniqueness of objects. So we just created 2 objects, thing 1 and thing 2, using object.new. They're going to have the same set of properties because we used the same approach to create them, object.new. But if we look at thing 1.objectID and then thing 2.objectID, what you can see is they're 2 actually different objects. They don't refer to this, they don't have the same ID. And when we had that on the board earlier and I showed we've got references and then you have the actual memory locations, you could think of this object ID as sort of the way to say that's that memory location that you're pointing to on the other side. So these point to 2 different places in memory for their objects. I talked about how nil is a little bit different. So if we did foo.nil, foo equals nil and bar equals nil. If we do foo.objectID, we get 8, and bar.objectID, we get 8. That's because there's only ever one nil object. Anything that is nil in your code at any point in time is just pointing to that one nil object in memory. There's no other locations that will ever hold nil. Yep, all I did there in that code, very simply was going back to our references and what they're pointing to is if this is our memory location of what we're pointing to, there's one place very far up in the Ruby code that has nil. And it's the way Ruby wanted to handle it. So there's just this one nil location. Now these are our variable names, our references. And I created foo, and it points to nil. And way down here, let's say, we create bar. And when it's nil, it points here. There's no other place in actual memory that's ever going to have nil, just that one object. Everything that ever has nil is pointing to the one instance of nil.
Can you think of it like kind of as a bookmark? So you have a book and then a nail is just in one page in one paragraph, and if you want to bookmark nail, you can just go to that one page all the time.
Sure.
There's no other nail. So the variables can be the bookmarks to that one little section in the book.
Right. Yeah, I think that's useful. And then what we did with thing 1 and thing 2, instead was, even though they look, what their data is looks similar, at least right now. I'll leave nil up here. Here we had thing 1. And down here we had thing 2. I have a hard time with those curves. And those are pointing to different actual locations in memory. So this is the object of thing 1, this is the object of thing 2. They're not the same actual object. Now, what we can do, and this is where the way that we called methods and stuff worked as well, is we can make, we looked at this a moment ago, should just be able to step back up. Thing 1 object ID, thing 2 object ID, they're different. Now if I go thing 2 equals thing 1, and thing 2 object ID, you'll notice that something changed here, right? Instead of this object ID, it now has the same object ID as thing 1. So what actually happened when I just made that equals was, instead of copying it or doing anything else, it changed the reference of thing 2 to now point to the same place as thing 1. So that means if we change a property on either one of them, let's add something to thing 2 dot. It's not going to let me do that, is it? Add a property in an easy way.
No. I mean, I don't know.
Yeah, I don't know how to do it. Okay.
Send? No, I mean,
I'll have to look that up.
yeah, I see what you're saying.
Right? I mean, I know I can do this, and I'm going to do it in a minute. I may as well do it now. But thing 2 dot high. So what I did here was added a new method to thing 2. And we'll go over that in a little more detail in a moment. But I may not point to the same stuff now. Let me see. Oh, thing 1. I called it off of thing 1, thing 1 dot high. But I created it on thing 2. And it worked because, remember, I changed them now to point to the same object. Before, when they pointed to different objects, that wouldn't have worked. So if I recreate these again, object.new, I'm going to create new objects and assign them to these. And now I'll do the same thing I did before. Def thing2.high. I can call thing2.high, but if I try and call thing1.high, it's not going to work. Because I added it only to that one object, and they're pointing to different objects now because I recreated them.
I guess another interesting thing not to miss is that the dot new on object is a method.
It is the method on object, yes. And we'll talk about that just a little bit more. So we talked about object uniqueness now. You can check whether it's a different object by looking at the object ID. That helps tell you the uniqueness of this object. Even if they look the same, things that look the same can still point to different areas. We have hello now, which has hello world. We could have just straight hi equals hello world. And as we've learned before, hello and hi are actually different values. They're different objects, even though they have the same content inside of them. Yeah?
So the two reference the both is same information. And then how about the one reference, one reference going to two?
Point to multiple locations. It's a good question. Not really. However, we've already been introduced to something that does that sort of under the covers, and that's the array. An array is the way that you do that. Because in reality, what's going on with the array is you don't have one memory location. You've got a series of memory locations, and you're pointing to them with your reference. That's how they work. That's also, by the way, why arrays start with a 0 instead of 1. Because the idea is if I'm pointing to a series of memory locations, then what I want to know is how far off of my original location do I need to go to get to a different value? So I need to go nowhere off my original location if I'm just getting the first value. That's why 0, 0, no change. But if I want to go, I need to go one more to get to the next location.
It's like movement, zero movement.
Yeah, it's like 0 movement is what I need to do. So now we've talked about this. Now let's look at how we can get the object type. So we know we've learned different object types. How can we actually look at that? The way you do that is look at the class method on the object. So hello, that's a type of string. We had the answer before, right? That was a fixed num. We also created this names array. So what type of object is names? Array. Ah, good question. Thing1.class is object. And it's because I used, what did I use to create it? Object.new. So the object type that I created was object. We'll get into it more, but objects can inherit from other things, and object itself is like the base low-level object in Ruby. So thing2 is also going to be object. Yep. This is how you can find out what type of object you're working with when you're working with objects. Remember, everything is an object in Ruby. True.class. Oh, I didn't create lowercase, right? It's true class. So how about false, lowercase? False.class, what's that going to be? False class, yep. And I don't even have to actually create a variable to do this. 42.class is a fixed num. Once Ruby's evaluated it, it's an object in the code that it's working. So that's how you're going to find the type of object when you're working with stuff. I think we've already gone through this pretty well, but references and instances, that's going into what I was talking about here. You've got references with the variable names. and they point to instances of the objects, which have the actual values in them. So I don't think we have to step over that again. I think that works pretty well. And then we also talked a little bit about how we can add a method to an object. That was, we did that just by doing def on it. So now thing 2 has hi. And we added that just by defining a method on that object. Instead of just using a plain method name, we use the object. So if I wanted to add a method to hello, I'll use this dot notation. And what should I add to hello? What? All right, let's add a by. What's this method gonna do? There we go. Now what I've actually done is I don't have just the raw object that I started with. I'm able to add methods onto it that can do additional things that I wasn't able to do before. It's been a little hidden in terms of stuff that we've done, but everything that we've worked with so far has been that same way. We've talked about these methods. We had names and we did names.methods. Here's a long list of methods that exist on this array. These are all very similar to what we did there. These are methods that operate on that array. One of the useful things to think about or to remember with this is what makes a method different than just a pure function, although we don't really have those in Ruby. And that is, for example, on names, if I did names.sort, do it up here so everyone can see it, I get a sorted version of the names array out. But do you notice anything unusual when I call names.sort versus if I had a sort method? What's that? Huh? Well, if I wrote this sort method by myself, if I were to write a sort method and I wanted to sort an array, what would I have to do? What? Let's say I want to write def sort. What do I have to do here? I want to sort an array of some kind. I'm going to create a... I have to pass a parameter. I have to pass it in an array, right? I didn't have to do that on my sort up here. There's no parameter I had to pass. And that's because methods on an object have access to the properties on that object. The properties on this names array are the names. So it's possible on this sort method, it doesn't have to take in its own object as an argument. It has access to that information. Now we're not working with that yet. We'll get to that pretty soon. But that's why you have these methods that can operate directly on an object, names.reverse, that don't need to take any additional arguments if they're working just on the content of that object, because all that information is already contained in that object, and it can work with that.
So those names are accessible to methods inside of the class. Is that how it works?
What?
The names.
Oh, we didn't talk about classes yet. There's no classes.
Okay. It is so, but is that kind of the thinking though? I'm trying to like figure it out how it would not require parameters.
Yeah, we'll talk about it a little more.
Okay.
I just want to sort of point it out. Part of the reason, I mean, you can think of an object as this. We talked about it. What was the word we used? Does anyone remember? Encapsulates, right? Oh, stepped out of it. It encapsulates. So this object has encapsulated the state, aka the array values, and the methods. Since it's all encapsulated together, those methods have access to those values and can manipulate them or read them without having to have them passed in directly. It's because it's all part of that same object that you're working on. We'll get into that in a lot more detail over the next few classes. I wanted to start with objects because a lot of times people will start with the concept of a class. We'll get to that later, but classes are not a direct mapping to real world items. Objects are direct mapping. We've got an actual laser pointer and an actual rubber duck, but classes don't have the same analog in the same way, so they're a little harder to understand. It's easier to start thinking about objects and then go down into how do we create objects? How can we create a bunch of similar objects? And that's when we'll get into the underlying bits of classes. Any questions on what we covered?